Hi everyone. According to my analytics, many of you are also interested in finance topics, and maybe, like me, you've recently seen many of these videos in your feeds, whose essence is that once you've made your first 100k, the compound interest effect really takes off, and you earn money while sleeping. This is often underpinned with quotes from Charlie Munger and Warren Buffett and supported with beautiful graphs showing exponential growth. It seems almost too good to be true, doesn't it? Maybe it is. In this video, I want to show you what can really happen with your stock investments simulated based on historical values. We will use Python to create a Monte Carlo simulation to simulate various outcomes for investments and see what phrases like average 7% return per year can actually mean. Before we start, a few estimation questions for you, and you can feel free to write your ideas to me in the comments. We invest 100k in stocks for 30 years with an expected average return of 7% per year. How much capital do we get out in the best case? How much in the worst case? What is the probability that we will have less than 100k after 30 years? And what is the probability that we have more? Okay, before we start with Python, first a little bit of theory. We will use a so-called Brownian motion for the simulation. Brownian motion is a mathematical model that allows us to simulate the random movements and fluctuations of stock prices. In the financial world, it's used to generate many possible scenarios of price developments. This way we can depict a wide spectrum of possible developments of our investments and better understand what could happen to our money in different market situations. I will provide you a link to the model in the description. Here is the formula of the geometric Brownian motion. I will show you how we can represent this in Python code, but in an absolute quick run through, as perhaps part of the audience is more interested in the results of the calculations instead of the Python code. You will find the link to the code in the description, so you can actually play around with the numbers yourself. Okay, first with the code, we start to import NumPy and matplotlib. This is done because we want some fast calculations. This can be done with NumPy, that's written in C, and a very powerful numeric calculation library. And matplotlib is in the data science community very popular to create plots. So first we start with creating the parameters. We need an initial stock price. Actually the price does not really matter because we only calculate shares, but we set it to 100 as a default value. Then we create the mu value. This is the expected return per year. So we set it to 6% with 0.06. And after that, we will create the sigma value, and that's the volatility. So sigma represents the risk of our investment. So if the volatility is very high, we can even with a high expected return have some kind of large fluctuations, but that can be in the upper direction and also in the lower direction. Okay, then we will set a t variable, and this is the time period in years. So if we set it to 1, the Monte Carlo simulation will only simulate a single year. Next is dt, that's a time interval, and we divide 1 by 252, and we do this because these are the trading days in the market, so without weekends and days like Christmas. If you multiply the time period in years with dt, we can create the n steps variable, so these are the number of time steps in our simulation. Then we set the number of simulations, so we want to create 1000 simulations to see different results. Okay, then we need our variables for our behavior. So for example, if we want to create a share savings plan, we will set that value, for example, to 100 or 200, whatever we want to save, and also start with an initial investment. For example, we start with 100k in stocks and buy so many shares. So for example, in this case, we would be able to buy 1000 shares of the stock. And then we can create our simulation. Okay, first we will create an initial array to store our values. So we will create an array of zeros with the prices, which we can then update in a loop, also create the shares and also the savings. Okay, then we will create the initial investment of the shares. This will be stored in the array at the first position. And then we can create our for loop. So we will create a loop that iterates over n steps. So this is the start value and this is the end value. So we've got so many steps to calculate. Okay, after that we will create the Brownian variable, and this creates a normal distribution. This is a standard variable for the Brownian Monte Carlo simulation. And this Brownian value will be put inside the formula and then create a new price in each step based on the values we put inside this formula. So this will be dependent on the values we created here. We also want to take into consideration the current step. So at the end of each month, so we've got 21 trading days in a month, then we can buy new shares. And we want to calculate how many shares we can buy, and then we buy those new shares and set it to a new value here. Otherwise, the shares remain the same. So the shares from the day before. With this information, we also want to update our savings and based on the number of shares and the current price. So we set the savings array also to the new value here. Okay, this is everything we want to do in our for loop. And now we want to calculate some other values we want to display on the screen for the user. So the first value is the total deposits, and this is the initial investment plus the monthly savings multiplied by 12. So we save that for each month and multiplied by the number of years. Okay, then we want to calculate the average savings of each simulation, the minimum of the savings, the maximum of the savings. Then we want to calculate how many of the investments are below the initial investment and use that value to calculate the probability to be below the initial investment. And we do the same for the probability to be above the initial investment. So we can calculate how likely it is to be above or below the initial investment. And then after this, we will just create a very large plot with a header and store everything here inside a text string and display the text string here inside a plot. So that's a script, but we also have got an app.py, and actually this is just a little bit better code, but the functionality is the same. And we built a GUI around it with tkinter. This is a standard library for creating some user interfaces for desktop applications with Python. I will not go through that code because it's a different tutorial, but I can show you the results in a little bit better way. So we run Python and then app.py, and now we can see a little window will open where we can set our values to make some simulations. So let's start with a very basic example. So I set the expected return to 7%, and the volatility, that's the volatility I found on Forbes. That's the historical volatility of the stock market. And now we set the time period to 1. So what is the probability to get positive or negative returns with 7% expected return, but this kind of volatility? So let's run 500 simulations, and we set the monthly savings to 0. Start with $1,000 of investment. So if we start with these numbers, we can see these are the results. So we start with $1,000, and you can see a lot of numbers are actually smaller than $1,000. So the average savings are $1,076. The minimum are $652, and the maximum is $1,663. So there's a lot of variation here, and you can see the probability above the initial investment is around about 60%, and below is a little bit smaller than 40%. So for 1 year of stock investment, it's more or less a coin flip. So is that surprising or not for you? So if we change the numbers a bit, let's say we increase the volatility a little bit, let's say to 5% expected return and volatility a little bit higher, 20%. So then the numbers are even lower. So that's even closer to a coin flip. But again, let's set it here to 1.5. These are the historical numbers. And now let's turn the 1 year period into 10 years. So how likely is it to win or lose in 10 years? For 7%, the probability to so-called win is more than 90%, and to lose money is less than 10%. So on average, you doubled your money on the stock market for 10 years. But as you can see, there are actually also numbers where you lost almost 70%. So this can also happen in a 10-year period. These very large returns are of course not guaranteed, but they are very likely. So now let's change it to 30 years and do that again. And as you can see, there's only a 2% probability that you lose money on the stock market with the historical numbers over a period of 30 years. But again, it's not impossible to lose money in the stock market even over a period of 30 years. So these exponential curves, you can see there are only a few of them. Most of them are quite here in the middle. So these returns are not guaranteed. This is what I actually want to criticize about most of these financial so-called gurus, that they claim numbers as guaranteed. But stocks are very risky, and you have to be aware when investing in the stock market that you can of course lose money even over a longer period of time. But of course, as you can see, it absolutely makes sense to invest money in the stock market with these historical numbers. Okay, let's now have a look at a more realistic example. And instead of purchasing stocks once and then waiting for 30 years, we will invest our paycheck regularly, let's say 200 euros or dollars per month. And at the end, we will take a look at the result. So the probability might be wrong here because we start with $0 and the max will be compared to our initial investment. So there's a little error in this calculation, but we can now compare the minimum with the total deposit. So we can see that even over a period of 30 years, we can still lose money in the worst case, but on average, we made a lot of money. So if the markets went well, we can see we can now buy a little mansion with a nice car and a pool. But if everything went very wrong, we can see that we only have now half of our money left. So even over 30 years, we can still lose a lot of money in the stock market. And this is really something I want everyone who wants to invest to be aware of. 7% per year are not guaranteed. Stocks are risky. And yeah, play around with the values. You can get the code in the description and tell me what you think about this kind of simulation. Thank you very much for watching. See you. Bye bye.